The diagram's as good as it's going to get. We have now made two spiral antennas for the probe, just for 2.4, 2.5 gigahertz. Why spiral and why not another type? Because it has circular polarization. And if we put something with vertical polarization there, the probe, when it rotates on its axis, and it will inevitably rotate, will have a dead zone then. That is loss of communication. Out of all that we tested in the field, we went away a kilometer, we tested different antennas. This is this spiral one with 3 turns that showed the best results. That's why we made 2 such antennas. One is transmitting and the other one is receiving. The antennas will provide communication between the ground station and the probe. Communication is needed to transmit, as I just said, a video signal or some kind of telemetry. This is exactly the system that we will test. We can put it on an unmanned airship. Put this antenna in mass production. It's simple. You calculate the impedance transformer once, so that it was, well, and the spiral, and the directional pattern. It can be 10 turns or 20, then it will be sharply directed. I don't know. There is nothing much to do to put them in serious production. In order to communicate with our stratospheric vehicle, we built a ground transceiver system consisting of 3 directional horn antennas and the transceiver itself. In the future, the system will be used to receive signals from an unmanned airship. I'm now in the process of assembling the digital transmission module system, which consists of the amplification board, the transceiver and the power supply system. The transceiver, which transmits the image to the amplifier board, which transmits the image to the antenna and transmits the image to our antennas, which are on Earth. Well, this board is responsible for powering the onboard systems. The power system has 3 connectors. These are the power input, power to the GoPro and power to the amplifier. The amplifier board consists of the board itself, a shell that protects this board from interference. The amplifier board has a fairly large power output, so the system is equipped with a liquid cooling system. The liquid cooling system consists of 4 copper tubes that are soldered to the base of a copper plate. Down in the module is the battery compartment, which consists of 4 battery packs and a pump that handles pumping the fluid of the liquid cooling system. I will now do a pressure test of the liquid cooling system to make sure that it is tight in the rarefied atmosphere. I apply 7 atmospheres of pressure. The system holds well. The manometer arrow stays in place. Now we supply 7 atmospheres of pressure to the system. During the flight, the pressure in the liquid cooling system will not rise more than 1 atmosphere. That's a 7-fold safety margin. Our Advanced Technology Department has developed a prototype of a stratospheric digital data transmission module. Future modifications of our module can be used to carry out stratospheric communications on long drifting vehicles and replace expensive satellites that cost hundreds and thousands of times more, including launch. Long-range stratospheric vehicles will provide communication and internet to hard-to-reach regions and will also be able to perform a variety of tasks, such as aerial, photo and video survey. The system will eventually be used in a near-term project on unmanned airships. Connected the radiators of the liquid cooling system to a group of sealed connectors that are located at the rear. This is the shell of the long-range stratospheric communication apparatus. The shell is sealed, moisture-resistant, and it will allow the apparatus to stay afloat in the event of a landing. There are two radiators on top. They are passive and they are cooled by oncoming airstreams during takeoff or landing. Two auxiliary transmitting antennas, a flashing beacon, and on-off toggle switches are located here. On the front, we have two action cameras. One action camera records, the other action camera records and transmits the video signal back to Earth. During the past launch, our stratospheric vehicle landed in the crowns of trees in the forest. We searched for it for an hour and a half in the dark. Now I've installed a flashing beacon to better visualize it. Inside the shell is a thermal insulation circuit that protects the batteries from low temperatures at high altitudes. Temperatures at 30 kilometers altitude can drop to minus 50 degrees. Two antennas are installed, a transmitting antenna and a receiving antenna. The antennas are spiral. The same antennas are installed on lunar, rovers and satellites. These antennas allow to avoid problems with signal polarization. The antennas are equipped with two covers. They also act as buoys in case of grounding. That's it, guys. I'm done.
Отлично, все есть.
Great, everything is there.
Иду. Так, мы отрабатываем канал связи.
We're working out a 20 or 30 megabit channel of communication. We're going to use it on airships in the future. We need to make sure that it's reliable, that there are no gaps, and that it will have maximum range.
Так, жижа гоняется.
Okay, the fluid's running.
Маяки проблескивают.
The beacons are flickering. What's going on, Volodya? That's a launch of stratospheric apparatus, the second experimental launch of the peak launch. Before the launch of the long-range apparatus, which will be launched, we're now testing radio equipment, video recording and capturing transceiver, satellite communications, direct transmission of high-resolution video without delay directly from the stratosphere. Here comes Dennis, testing all the systems on his vehicles. Last time, I guess 1.5 systems worked out of 6. This time we hope for a little better positive results.
Поехали, короче.
Let's go.
Оба канала, то есть на прием
Both transceiver channels are working perfectly. I mean, it's been how long? 5 minutes or so of flying.
Я даже антенну не двигаю, она
I'm not
нормально
even moving the
направлена
antenna.
туда.
It's pointing normally that way.
Всё хорошо.
Everything's fine. This is the mobile flight control center. There are 2 monitors, a TV, portable internet, a whole local area network wired throughout the bus, and a lot of handy perks just to make it convenient and technological to conduct launches. Now the altitude is already 1200 meters, we have passed the clouds. We have a vertical speed of about 6 meters per second. It will be about constant at all echelons. The horizontal speed is about 11 meters per second. Green is the GPS altitude, and just by using this green track, we can track when we've lost GPS signal and when we have it. There was a breakup at 22,000 meters. We're coming down. Speed is now 34 meters per second. It's 20,000. We've lost 2 kilometers in less than a minute. Now we're going to gradually enter the denser layers of the atmosphere, and the vertical velocity will start to decrease. We'll start to descend more gently. The rupture of the shell occurs because as the balloon rises, the pressure around it drops, but the amount of gas in the balloon remains constant. So the gas in the balloon expands, and the walls of the balloon begin to get thinner and thinner, and at some point the thickness becomes very small, and the balloon simply ruptures in the weakest place and it bursts, so we start to go down. The rupture of the shell is a planned event, and moreover it is predictable at what altitude it will happen. Today we had a rupture at the calculated height with an accuracy of 100 meters. The stratostat has already flown far enough, plus it is descending, and its altitude is already about 9,000. It's starting to go slowly over the horizon. We don't have direct radar visibility of it. We're starting to look through the trees, and so the signal is lost a lot, so we can't get the video. There it is, the Decepticon. Digging the ground with its cameras. Have you found the apparatus? Yes. Any damage? No. Is the camera working? It is. Still working, yes. Nothing's happened, everything is intact. Just the styrofoam buoys fell off. Otherwise it's safe and sound. So much weight dropped from such a height and everything is intact. The antenna is a little bent, but that's just a small thing. Most importantly, look, it is airtight. Antifreeze is inside. Nothing leaked out, everything works.